That's our S channel. Today we're going to take apart this engine. Today we'll start repairing this engine. Later we'll assemble it, start it up, possibly right on the table, install it and so on. Thought maybe I'll paint it, not sure yet. What engine is this? This is an engine made in Bulgaria, as we can see, made in Bulgaria 1984, almost the same age as me. The engine model is listed here, but the plate is pretty worn. Later I'll get info on this engine and add subtitles with its model and specs. So, this engine was taken from a forklift. The forklift at our company is made in Bulgaria by the Balkancar company. Since I work at the company, this engine has never been repaired. I've been working here for almost 25 years, and during my time, this engine has never been repaired. So, this forklift has appeared in my videos more than once. It's the forklift we use to remove and install all the engines from buses, trucks, and so on. Before bringing it to my workshop, they washed it. There was a centimeter thick layer of dirt here, and now you could say it's already clean. Well, there are still some spots where dirt remains. So here's what we see. We see that there's sealant on the oil pan, which means at the very least the oil pan was removed. Well, I don't have exact information about how many engine hours this engine has, how long it worked without repairs and so on. Why was this engine removed? Well, let's just say it's time. It burns oil, has blow-by, poor power, low oil pressure, and more. So basically the whole set of problems of a worn-out engine. The cylinder piston group is worn out, and the crankshaft and connecting rod mechanism is worn out too. Here, I took a look, and you can even see by the ring how worn the teeth are. This engine may not have been serviced since 1984, so we're going to disassemble and inspect it. We can see that the engine was brought to me with the transmission. The transmission here is an automatic hydraulic transmission. We can also see it's from 1984. And it only has 2 gears, meaning forward and reverse. That's it. The lever has 2 positions, forward and backward. So overall the transmission is fine, it works. The only issue is that it's leaking oil, probably from the gaskets or somewhere else, but basically oil is seeping out, and I don't know, maybe I'll have to take it apart. Just replace the gaskets, maybe put some sealant somewhere, and so on. That's not certain yet. There may be another video on disassembling this transmission. Basically the engine is about the same size as the Volga engine, I guess. The Volga 402 engine is similar in design to the D245, or rather the D240. Like the D240, it has no turbo. At the front, there's a timing mechanism with gears, timing gears and 1 pulley. Here's the fuel pump and the hydraulic pumps, one here, another there. They're basically the same. The cylinder head has the manifold on one side and injectors on the other. Its construction is much like the D240 engine. The oil filter is also side mounted, among other features. I don't know the engine's weight, but lifting it with a hoist, you can really feel it, especially here. So this cover here, as I understand it, is thick cast iron. This housing itself is also thick cast iron, so you can really feel that it's quite heavy. It's likely similar in size to the Volga's 202 engine and about as heavy as the PAZD 245. If I learn the engine's weight, I'll add it to the captions. Alright, let's start taking this engine apart. First, I'm taking off the gearbox. So, as we can see, there are about 10 bolts around the gearbox. Also, something I noticed, you can see that the gearbox on top isn't tightened properly. So it's all packed with dirt here. And that's how the gearbox was attached. If we look from below, the gearbox fits tightly. There's just about a 1/10 of a millimeter gap here, but on top it's a couple of millimeters. I don't know what this is related to. Maybe it's packed with dirt there. Maybe the bolts have loosened. Well, anyway, let's take a look now. First I remove the gearbox, then begin disassembling the engine. I take off attachments like filters, pipes and the fan, followed by the valve cover and cylinder head. We're taking the engine apart step by step. I'm actually curious myself. Basically, it's my first time working on this kind of engine. I've never worked on an engine like this before. Honestly, I can't even say the exact model of the engine. I'll need to look it up in the manuals. There are manuals for this loader. What else do I want to show? Here's a fuel pump. So, it's a mechanical one with a primer, like on the Zavolski motor plant 511, on Zavod Imeni Likachova engines and so on. So, this is our low pressure pump. Alright, let's start disassembling this engine. Let's go! I removed the gearbox. This one, yes, that's yes. Honestly, I didn't understand what happened. I had to drain the oil to remove the gearbox, since you can't take off this part otherwise. You can see there's a ring here. So, it turns out this is the torque converter. It stays attached to the flywheel. Well, that makes sense. It has to come off somehow. There are no holes on the engine side, on the housing, so that's why it's designed this way. The gearbox itself splits in half. The torque converter stays bolted to the flywheel. Interesting. So, this cover here keeps the oil from getting to the flywheel. Here, it's just metal to metal. Interesting. On the gearbox side, a sealing ring is used. The gearbox housing presses against the flywheel cover. So now I somehow need to remove the torque converter from the flywheel. I'll use a 6mm hex key to unscrew the 12 bolts around the circle and check their length. Maybe they're attached to the flywheel, holding and fastening the torque converter to it. Well, I don't think you should have to unscrew all these bolts, split the torque converter and remove all the discs. And only under the disc there are some bolts, so that would be very difficult, although I don't know. Alright, let's unscrew these bolts for now. Yeah, since the bolt is short, it's unlikely it'll do anything. So what did that do for me? Nothing. So, it turns out I need to unscrew all these bolts around here, take apart the transformer, and then underneath it there will be the mounting of the transformer body to the flywheel. I opened the transformer. We can see there are no clutch discs here, though I expected a set. Instead, there are blades and turbines. Oil hits these blades, pushing against them to transmit torque. That's right, here we have the attachment to the flywheel, or rather, this isn't just the attachment to the flywheel, this is actually the flywheel itself, so the body of the transformer also serves as the flywheel. I'm keeping the flywheel on 2 bolts for now, and will remove the cylinder head next to see what happens. I think I've figured things out here now. I'm starting to remove the cylinder head, working from the front, taking things apart there. We can see this amount of soot in the intake manifold. So I've removed the valve and the cover, and we can see this amount of buildup. There's a strong burn smell, and these layers, this much buildup. So what can I say right away? I've removed the cylinder head, and what do I see? Probably a lot of wear. On the first cylinder, the first compression ring might be broken, and there's a ridge near the second ring. Well, basically, I don't even know what to say yet. We'll keep taking it apart and see. So, as we can see, the fuel pump is removed the same way as on the D245. You unscrew this nut here, and the shaft with the pump comes out that way, while the gear stays under this cover. So we can see that oil goes through the splines, right? Turns out all the sealing is done by this washer. If this washer let a little oil through, then oil would leak through the pulley. So what do I usually do in these cases? I degrease the splines and coat them with sealant. That way I eliminate the possibility of oil leaking through these splines. I remove the front pulley and I'm unscrewing the cover around the edge. How many bolts are there? I'll open the cover to check the timing mechanism. So, what do we see here? This is the crankshaft, this is the camshaft, this is the intermediate gear, the fuel equipment, and two pumps, two hydraulic pumps. So, the hydraulic pumps remain arbitrary. There should be timing marks here. I see a mark on the camshaft. Again, the thing is we have 3 gears and 1 intermediate gear. To align the timing marks, we might need to make several dozen rotations here. How many rotations did I make? I did about 2 dozen, and as you can see, the marks lined up. Everything's fine, nothing needs to be removed. What else do I want to say? I'm looking at this system, and it's exactly the same as on the D245. There's the crankshaft, camshaft, pump, intermediate gear, hydraulic pumps, and the power steering pump. Everything seems the same, but here everything is made so neatly. This intermediate gear, for example, it has absolutely no play at all. How many engine hours has it run since 1984? Nothing is worn out anywhere. There's no metal shavings anywhere. No bushings or washers have been crushed. I mean, everything is just excellent. See, it can be done. I don't get why everything is done so poorly on the D245. Alright, so I can't get the pump out. There are 2 bolts down here. I need to remove this pipe because it's heating the oil filter housing, and I can't remove the oil filter either because of this pipe. So, it turns out there's a strict sequence. First you remove this pipe, then you remove the pump, and then you can remove the oil filter housing. Alright, so now I'm going to turn the engine over and set it down on this surface. I'm not removing the gasket on purpose, so I don't scratch the block in this spot. I'm now removing the studs. I already unscrewed one, and I'm unscrewing the second using the nuts. So whenever I show in a video, for example, when I'm unscrewing or screwing in studs, someone always leaves a comment saying, buy yourself a stud remover. So I want to say I have stud removers of different brands and models, but any stud remover damages the threads. Literally any of them. All stud removers damage the threads. That's why it's easier to just use nuts to unscrew it. You definitely won't damage the threads, and it's not really hard to screw on two nuts. Tighten them and remove the stud. It's really not a hassle at all, but at least I know for sure that my threads won't be damaged and so on. Here's my comment on just buy a stud remover. If you know of any that don't damage threads, please send me a link. I'm interested. You can use a stud remover to unscrew the stud by gripping this part of the body, not the threads. But there will still be dents, burrs, and so on left on the body. I prefer working with nuts. I removed the oil pan and immediately noticed the quality of the oil pickup. That is, it rests against the oil pan and it's spring loaded there. So there's a spring here. The oil intake isn't between the pan and pickup. There's a gap. Oil is drawn directly from inside the oil pan. It's the best option. I don't know why other engines don't use it this way. Before this, I had an engine, a contract engine from Poland. I showed there that the oil pan was deformed. And the oil pan with its bottom wall, it blocked access to the oil pickup. That is, oil couldn't reach the oil pickup. It didn't block it fully. Only about 3 millimeters or even 1/10 of a millimeter remained. That situation can't happen here. Here, everything is done properly. Now I'm removing the oil pickup, or actually probably the whole oil pump assembly. I'm taking off the oil pump with the pickup, and then we'll take out the pistons. So, I checked the oil pump. I can't remove it until I take off this front cover. The pump is mounted right under the cover on this side. I need to remove the front cover now. Everything about it is clear. Here are the bolts all around. The only thing is that under the camshaft gear, there are also bolts. Here is one bolt, here is the second bolt, and here is the third bolt. But we can see that the hole is very small. No socket will fit in here. E. Plus, it's not aligned with the bolt, so the bolt is slightly off center from the hole. So, I need to remove this camshaft gear first, and only then can I unscrew these bolts. So on the front cover that I removed, there's a thrust washer here. I'll show it later after I clean it. I'll show you. So you remove this front cover and the camshaft comes out. About the camshaft, visually everything is perfect. Absolutely ideal. You can't even see any wear on the cam lobes or anything like that. The camshaft is in perfect condition. I've removed all the bolts, but the pump still won't move. I had to remove the ring from here and take off this gear. We can see there's a shaft here. This shaft is pressed into the main cover and the whole pump is basically mounted onto this shaft like this. So it's quite an interesting and clever system. So I removed one connecting rod bearing on the third cylinder. We can see there are these kinds of scratches. That means some metal shavings have already gotten in here. There are these scratches. Now let's look at the bearing and see what we have here. There's some kind of number here. That's it, just this number. Ah, well, here's the standard, probably ST standard. Basically almost the same. So I take out the pistons. And we see that we have 3 compression rings, 1, 2, 3, and 2 oil scraper rings. Besides, the oil scraper rings are quite wide. They're probably 6 or 7 millimeters. So we see that the oil scraper ring is stuck. Carbon deposits are everywhere. The oil scraper rings are worn, causing oil to burn and enter the combustion chamber. The piston also has carbon buildup. The bushing is basically not worn out, almost not worn out at all.
we'll probably just leave it as it is. Well, the pistons will most likely need to be replaced. Here, we likely have dry sleeves that won't come out. I need to scrape off the gasket, but I couldn't remove it. When I tried, it just began to delaminate. I can't believe the engine's run since 1984 and the gasket is just so, well, in that condition. I mean, it's steering, it's stuck to the block. There's no corrosion under it anywhere. It hasn't blown out anywhere. It hasn't rotted anywhere. So, you can see it's steering, but looks like new inside. I couldn't remove the piston by hand, so I had to use a hammer and a piece of wood. And we can see that the top compression ring is broken on it. Like I said, when I opened the head, I checked the wear and said that maybe the top compression ring is broken on the first cylinder. That's exactly right. We can see it's broken into several pieces. Here are the pieces falling out. We can see that the main bearings, like the connecting rod bearings, have scuff marks running along the oil channel. So we can also see that the bearing is standard. Here's the inscription standard. About the shaft, I won't say anything for now, but most likely nothing happened to it. Visually I see that it's in good condition. But that's fine, we'll measure it later and then draw some conclusions. So I'm unscrewing the other 4 main bearings and removing the crankshaft. So I want to show you what the main bearing shell that sits in the block looks like. It doesn't just have a groove, it has this kind of hole, this kind of slot. The thrust washers are positioned in the middle. They're not on the bearing shell, but separate. You can see that the sleeves here are dry, so we'll have to send the block out for machining. So the tappets are basically the same shape as those on the 4th series Mercedes, like on the Maschinen Fabrik Augsburg Nürnberg 2866. I mean, in terms of shape, they're a bit different in size, of course. Overall, the tappets are still in good condition. So the engine is disassembled now, and it's time to sum things up, talk about what repairs are planned, and so on. Everything I'm about to say is just a preliminary summary for now, because I'll need to clean every part, wash something, measure, inspect, and so on. As I understand, the sleeves in the block are dry, pressed in without rubber seals. To install repair pistons, you have to bore the sleeves in the block. It's clear. Just clean and flush its channels. About the camshaft bushings, as far as I can see from here, there's no bushing here, it's just the block itself. The tappets stay the same and the camshaft also stays the same. I don't expect any issues with the crankshaft. I might clamp it in the machine and polish it. And I think all the bearings will be standard. Moving on to the pistons will be new, either standard size or repair size. In any case, the pistons and all bearings, main and connecting rod, will be new. The rocker arm, shaft and push rods need cleaning and inspection. The injectors will be sent for testing. The fuel pump will probably be tested as well. The camshaft, as I mentioned, will remain the old one. We probably won't do anything with the hydraulic pumps either. I'll clean them, replace the gaskets, disassemble the cylinder head, check the valve guides and valves, and follow my usual process. What else should I say or show? Well, that's probably all. We need to replace gaskets, oil seals, and similar parts. That's the work ahead. It's clear this engine wasn't used like a bus or truck and doesn't have similar mileage. It only ran in the garage, for example when something needed loading, unloading, or engine removal, etc. But considering that it hasn't been serviced since 1984, that's still impressive.
I researched this engine online. These engines were mainly installed on special equipment, mostly loaders, some tractors, and so on. I also found information that for some time they were installed on the bike. Well, I don't know if that's true or not, but there is information on the internet that this engine was installed on the bike. Most likely it's not this one or the D3920, but the DT3920. That one has a turbocharger and more power, about 90 horsepower. I also learned these engines are used in Olinovsky Automobilny Zavod vehicles. I think it's too heavy for Olinovsky Automobilny Zavod at 355 kilograms and the horsepower is low. So, what has already been done with this engine? I washed it, but as we can see, it's not completely clean yet. There are still some oil deposits left in some places. That's because there was a thick layer here, several millimeters. And now the block will be sent to another company to have the liners replaced. I assumed we'd buy repair pistons. If our standard is 98.5, the repair one should be 99 millimeters. And the liners would be bored out for these pistons, repair rings would be purchased, and so on. But we couldn't find any repair piston. I don't know, maybe they just don't exist at all for this engine, or maybe they're simply not supplied and so on. So new liners were purchased and standard pistons were bought as well. And now we need to remove these liners, mount the block on the machine and remove all liners and shavings before pressing in the new liner dot. After pressing in, machine the liners again to standard size. So that means the engine will be sent to an outside organization for this work. After that, I'll need to wash the engine again, and then I'll clean off these deposits that are still left. What else should I do with the block before sending it to the machine shop? There is old sealant in some areas, old gasket in others, and so on. Now I need to remove the sealant, gasket, and dirt with a wire brush. I also need to remove the mounting brackets. 4 nuts on one side, 4 nuts on the other side. I also need to flip the block over and scrape off the cylinder head gasket. I'm prepping the block, then we'll send it to the machine shop. Afterward, I'll handle other prep work. First, I need to disassemble the cylinder head and inspect the guides, seats and valves. Also, decide if it needs to go to the surface grinder. That's our scope of work. Let's begin. What else do I want to say? I removed the mounts and we can see there's black oil here, which means oil is leaking from the engine. These holes, where the studs are screwed in, are through holes. They go inside the engine. It turns out that oil seeps along these studs, along the threads, so I'll have to unscrew all these studs, clean everything here, and set these studs with thread locker. That means on this side and on that side as well.
Alright, about the valves. We can see there's wear on the valve from the seat, and the same goes for the seat itself. We can also see that this edge is already sharp. If I remove this wear on the machine, this edge will become very thin. The exhaust valves will definitely need to be replaced with new ones. There are pits and carbon buildup here, and the edge is sharp. There are also some chips in places. For example, on this valve there's a chip right here. There might even be a crack. Well, anyway, we'll have new valves. About the guide bushings, I don't know, they'll need to be cleaned, but if you try it like this, the valve goes in pretty tight. Maybe everything is clogged up with carbon deposit. The block is already with me. It returned from the machine shop and I've washed and blown it out. It was covered in diesel fuel. I used diesel fuel instead of coolant for honing, so everything was covered in diesel with some metal shavings from the machining. I've already washed and blown it out, so it's ready. What was done to the block? We machined the cylinder head mounting surface slightly, removing just 0.07 millimeters. The sleeves were replaced, then machined and honed for the piston after fitting the new ones. While the block was being machined, I prepped by washing and cleaning everything. I remember there were many oil deposits, sort of like grease. Even with diesel fuel, they were hard to wash off and regular washing didn't work. I had to change the diesel fuel multiple times. Most things are clean, so I'm starting assembly now. Well, here I still need to, for example, remove the old gaskets somewhere and so on, clean and degrease. In general, there's still work to do. I cleaned the crankshaft too. Here's the oil pan, oil pump, camshaft, push rods and rocker arms. The old pistons, connecting rods and covers are over there. So what else do I want to show? As I remember, there were these kinds of scratches on the bearing, on the main ones and on the connecting rods, some bigger, some small. Most scratches were near the oil channels on both main and connecting rod journals. Well, if on the bearing insert these are deep grooves, then on the journal itself it's just a pattern. You can see it, but you can't feel it with your finger, and I think that after polishing it won't be visible at all. But after polishing, of course, I'll measure it again. But I think there's no issue with the crankshaft. What did I notice? What feature? So we can see there are these kinds of drillings, right? That is, we have an oil channel, for example, going out to the connecting rod journal. And there are similar drillings on the main journals. On this journal, you can see we just have a hole like an oil channel. But if, for example, we look at this journal, we can see that the hole here seems like it hasn't been fully drilled through. As if, well, in general, the hole is the wrong shape. I want to review all this now. We need to figure out what this is. Either it's just a hole of the wrong shape, or it hasn't been fully drilled, or maybe it's some kind of swerve that's been rolled in and so on. So possibly as an option, the oil pressure knocked off some pieces of the swerve from here, right? And that's why we got these grooves on the crankshaft. That's it. But if we, for example, look from the opposite side, here we see a hole. The countersink is smooth. The shape of the hole is correct. I might have to take a drill
and go through this oil channel with it, right, to remove those burrs from that side. We'll revisit this question later. I'm clamping and polishing the crankshaft, then we'll start assembly. Alright, the crankshaft is ready. I've polished it, and now I've also blown out the channels. So I blew out anything that might have gotten there, maybe some shavings, abrasive, and so on. So the crankshaft is ready. The block is also ready. I blew out all the channels again and wiped them down. The caps are also prepared, washed and cleaned. The bolts are ready. Here I have the thrust rings. Here I have new bearings. Now I want to answer another question. In the comments, people often ask me what is that red stuff I use to coat the crankshaft bearings and so on. I want to show you that I use this kind of assembly paste. It's an assembly paste from VM Pato in aerosol form. So it comes in a can like this. I've been using it for more than a year now. Basically, I like everything about it. It's great. Let's start assembling.
before installing the crankshaft, I need to install the lifters. Well, you can install them later, but it will just be less convenient. Alright, set the wrench to 200 Newton meters and tighten the main bolts. Okay, I tightened it to 150 Newton meters. Now we set it to 200 Newton meters. And now we do the final tightening.
prepared the pistons for installation and want to explain briefly. So the pistons are new, the gudgeon pins are new, the wrist pin is new, and the rings are new. We didn't replace the connecting rod bushing since it's still in good condition. These are the pistons we're using now. That is, just 3 compression rings and 1 narrow oil control ring. If you compare them to the old pistons, those had 2 oil control rings that were both fairly wide, around 6 or 7 millimeters. In short, the pistons differ greatly from the factory ones. They arrive in these boxes without any markings or labels, and the geysers came in this kind of packaging too. I also can't say anything about this manufacturer. This is the first time I've seen this. I just install whatever parts they bring me. I don't make any decisions here. I've installed and tightened the crankshaft and also installed the connecting rods. The manual says these bolts are tightened to 200 Newton meters, and this bolt with a nut is tightened to 100 Newton meters. There's no 90-degree turn, so just 200 Newton meters, 100 Newton meters. Out of habit, I made marks so I know for myself that these bolts are already tightened. So the crankshaft is fully installed and tightened. Everything turns perfectly and all the connecting rods have this kind of play. That's it. Next I'll be installing the rear cover with the oil seal, the front cover, the camshaft, and so on. I'm installing the intermediate gear. Crankshaft, I've lined up the marks down here. This one's for the crankshaft, this one's for the camshaft, and this one's for the fuel pump. The needle bearings are put on. I also coat them with assembly paste and install them. I closed the oil pan, tightened all bolts, installed the cover, used thread locker, and checked the mount tightness. So what's next? I need to unscrew these studs. I remember everything around them was oily when I disassembled them. Here we have a through hole into the engine, well, into the engine crankcase, and it turns out that oil was leaking through the threads. I want to unscrew all the studs, degrease them, and apply thread locker on both sides. Then I'll install the mounts, possibly the pumps, oil filter housing, etc. I'm not installing the flywheel yet. It's cleaned, prepared, and on the shelf. I might need to flip the ring gear. I'll check now, since I haven't looked yet to see if it can be hooked or removed. If it's possible to remove it, I'll take it off, heat it up, flip it, and install it. Another thing about the flywheel is installed with a gasket. Since our flywheel is part of the torque converter housing, meaning there's oil inside it, a gasket is placed right here, just like this. There was a very thin gasket here, about 2 or 3/10 of a millimeter. The kit includes a Paranite gasket that's about 1.5 millimeters thick, so I think it's going to be too thick. Now I'll press it down as much as I can, but over time, from the load and the heavy flywheel with force applied, it adds up. I think this gasket will keep getting compressed. Yeah, it'll keep settling. That's why I'm going to cut a gasket from a thinner material using this template. We'll return to the flywheel later. First, let's try flipping the ring gear and making a gasket. Right now I'm working on the studs, maybe installing the pumps and so on. Then I'll flip the engine over. So, up front here, I haven't installed the fuel pump yet. I'll probably install it once the engine is flipped over, when it's already sitting on the oil pan. I'll install the fuel pump, close this cover, and put on the pulley. So that's the amount of work we have for now. We're continuing to assemble the engine. Yeah, I should have unscrewed these studs earlier. So the studs are fine. It's not a problem to clean them. Now, I just need to somehow clean the threads right here. Degrease them. Alright, I'll get some clean rags and solvent now. I'll thoroughly degrease everything there. I should have thought of this sooner. So I turn the engine over. I've already installed the pump. I'm installing the pump according to the mark. So there's a mark on the housing itself, and there's a mark on the pump itself. By aligning them there, you can slightly turn it right or left on the spot. But the pump was installed about the same way. You can tell by the old marks from the nuts and washers. So the pump was installed about the same way. I installed the pump. Now I need to install the gear here. So we see the crankshaft, the marks are aligned. There are 2 lines on the crankshaft and a dot on the intermediate gears. Next to the camshaft, we also see 2 stripes here and a dot on the intermediate gear. Now for the fuel pump, we see here we have 2 dots, and on the gear itself there is also a dot. The tooth is marked. So I installed the key in place, and I've already lined it up roughly how it should go in, and now I'm just installing the gear, tightening the nut, and basically that's it. I can close this cover, put on the pulley, and then we'll just have work left on the cylinder head and then on the gearbox. About the gearbox, I don't know yet, probably. I won't assemble the transformer. I'll see if I start the engine, I'll probably start it without the transformer. That's how it is. Now I'm installing the front cover. I cleaned it, removed the old gasket, degreased it, placed the oil seal. I applied sealant and prepared the gasket. On the engine side, I cleaned, chased threads and degreased it. Let's recheck the marks and ensure all timing marks are aligned. I've prepared the oil deflector and the washer. First, the washer is installed, then it's covered with the cover. Here I also apply a thin layer of sealant on the cover, close the cover, install the pulley and tighten it. And now we'll work on the cylinder head. Maybe someone noticed that I'm not using the air gun on this engine. Yes, the air gun, well, this hose broke on me. Quick release. Basically I need to figure something out, either rework it or take it to be pressed. Another thing, since this cover here has no guides at all, it moves around like this, right? There's a complication. I thought I should install the pulley first, then tighten the bolts. So, the idea is that the pulley will center this cover in relation to the oil seal, because right now I could tighten it unevenly. The oil seal will misalign with the pulley, pressing on one side and leaving a gap on the other. It's really unclear why it doesn't have any guides, why it moves around a bit. There's some misalignment. Well, as I said during disassembly, oil was passing through these splines. You can see, I coated them with sealant, and I think now oil won't get in here. Alright, so we continue assembling the engine, and next I'll be installing the cylinder head. So the cylinder head is already prepared. There will be a separate video about the cylinder head repair. I've already filmed and edited everything, so it will be a separate video. I don't know yet where it will be released, on YouTube, RooTube or Zen, so I have no idea what's going on right now, what's happening. That's why it's impossible to make any plans. So the separate video about the cylinder head repair will be released somewhere. So It turns out the cylinder head is completely ready for installation. Here we have a gasket like this metal asbestos. Well, I mean, it looks a lot like the gasket from the D245 engine. Honestly, I don't trust it based on how it looks, but since we don't have another gasket, we'll have to use this one. I also washed the bolt. We should also have two studs here. Here's one stud, and the second one should be somewhere around here too. Here's our second stud. I'll screw in the studs first, then install them. The cylinder head goes there. Next, we'll install the injectors and adjust the valves. We're finishing engine assembly, and painting will happen soon. I'll check which colors I have enough of for the engine. I can't say anything about the startup yet. We'll see how things go. Maybe I'll do the startup here on the table, or maybe the startup will only happen on site, on the vehicle, on the loader. We'll respond as needed based on the situation. That's our current workload, and we're continuing assembly. So I've installed the cylinder head and the bolts to 140 Newton meters. Already installed the rocker arm shaft push rods. Tighten the rocker arm shaft. Now I'm going to adjust the valves. Oh, and here's another thing we can see. The oil channel runs like this. Yes, so this kind of conical tube is simply inserted into the hole in the cylinder head. And here we have this, like a plug that secures this tube with a single ring on the rocker arm. So this is how oil is applied to the rocker arm shaft, and then through a hole it goes to the rocker arm bushings. So next I'll be adjusting the valves. The valves are adjusted basically the same way as on any 4-cylinder engine. There are two methods you can use to adjust them. First, bring one cylinder to top dead center. When the second cylinder's valves overlap, adjust 4 valves. After a full rotation, adjust the other 4 valves. Or you can bring the first cylinder to top dead center, adjust the first cylinder during the compression stroke, then follow the firing order 13 to 2 to adjust each cylinder's valves. You can bring the first cylinder to top dead center, on the compression stroke in two ways. First, turn the engine and watch the first cylinder's intake valve operate. Then set the piston at top dead center. So the second way is to turn the engine clockwise and watch the fourth cylinder. On the fourth cylinder, the valve should be overlapping. That means one valve should be finishing closing and the other valve should be starting to open. This is called valve overlap. At that moment, the first cylinder will be at top dead center on the compression stroke. The fourth cylinder will also be at top dead center, but during the exhaust stroke. And the reverse is true. When the first cylinder has valve overlap, the fourth is at top dead center on compression. So I turn it clockwise to bring the first cylinder to top dead center. I adjust the valves on the compression stroke, then install injectors, connect fuel lines and close the valve cover. And basically, that's it. There are just a few small things left to put back. Then I'll prepare the engine for painting or starting. We'll see how it goes. The engine is nearly assembled. I installed a new pump, attached the fan to the low pressure pump, fuel filter, hoses and the return line. My engine is assembled. I just need to install the oil filter and manifolds. As I already mentioned, I want to paint the engine and I also want to paint the manifold. I have some special paint for car exhaust systems and I want to use it to paint the manifold. To paint it, I need to prepare it by removing rust, cleaning spots and getting rid of carbon buildup. Alright, so the manifolds are clean and ready for painting. I've already prepared the paint. These are the leftovers of the manifold paint. There should be just enough for the manifold. I found yellow air drying automotive enamel in my supplies for this engine. The engine is already prepped for painting. I cleaned the intake manifold of paint and removed carbon buildup. So everything is great. I covered the exhaust manifolds, closed off and taped the hoses, put wrenches on the pulleys and covered the pipe connections. I put on the old oil filter. It will serve as a plug for now. I'll paint it, then remove it and install a new oil filter. That's it. The engine is ready for painting. I'll hang it on the hoist, move the table and we'll start painting. I forgot to mention, I don't have any primer. I found some paint, but no primer. We'll try painting without primer paint and see if it turns out worse or better.
The paint is too thick. I need to thin it.
As you recall, the rubber seal was crumpled, having come out of the groove and been pinched between the gearbox housing and cover. I installed a new rubber seal, added sealant, and we're reinstalling the gearbox.
Alright, that's it. I've installed and tightened the gearbox. Basically, the engine is ready to be installed. As you can see, the Bulgarian engine D3920 is disassembled again. It only took us a few days and I had to take this engine apart again. So now, I'll try to explain in a few words what happened, what went wrong. In the last video, you saw the engine start and run well. So, the engine ran at idle for a while and oil started dripping from the exhaust manifold. Looking now, we see the entire manifold covered in oil, with a puddle forming and oil dripping. Well, basically I thought this was a pretty normal thing. After an overhaul, oil gets into the exhaust system for a while. The sleeves haven't worn in with the rings yet. Also, a lot of oil is used during assembly. Rings, sleeves and so on are coated with oil. So I thought that a certain amount of oil is normal, and after it runs for a bit, this oil leak will stop. So the engine ran in the shop for a few hours at first, then the next day it was taken outside. It ran outside, well, it worked for some time, then it was shut off, then it ran again. All this time oil kept leaking from this joint. Then they removed the joint and you could clearly see the streaks. Yeah, they put a plastic container there, and after a couple of hours of running, it collected about, well, I don't know, maybe 20 grams of oil, 30 grams of oil, but it doesn't matter. So the next day they ran it in again. I mean, they thought it needed to run for a while. The rings could wear in a bit. Altogether, they ran it in for about 3 days. The oil leak continued and remained unchanged. So, what decision was made? They decided to take the engine apart and see what's going on. Why? They removed the cylinder head, oil pan, and pistons right there. Well, basically, in my opinion, there's only one reason here. It's the oil control rings. Yes, that's the design of the pistons with those oil control rings. So as I showed during the assembly, we had pistons like this, right? Apparently there are 2 oil control rings here. Both are wide like this. On the new pistons we have 1 oil control ring. and it's this narrow. Here, for comparison, we can also see that this piston has 4 large holes like this. The ring scrapes off the oil collects here, and it needs somewhere to go. There are special grooves on the ring, right along this groove here. Through these grooves, the oil goes into these holes and drains into the oil pan. So the ring collects the oil accumulates in the ring. It needs somewhere to go. So on this side we have 4 holes like this. On the opposite side there are 4 holes like this. On the second ring we also see 4 holes at the bottom. And on the other side there are also 4 holes. So we have 8 large holes like this, probably about 5 in diameter. Looking at this piston again, we have 2 small holes like this here, probably about 2.5 millimeters in diameter, maybe 2. This is an oil control ring. With this kind of design it just can't handle it. I'm not sure why they make pistons like this, since I don't have much experience with these engines. I've come to the conclusion that it's all because of the design of the oil control rings, the design of the piston itself, and so on. So as an option on this piston, you could, for example, drill 3 more holes or make them bigger as an option. Yeah, maybe that would give some results. At first, we wanted to reinstall these old pistons that were there, but then we decided to buy new pistons instead. So as you can see, I have 4 pistons here. You can see 3900 5K. Well, that means 5 rings. 5 rings per piston. So these new pistons were purchased, completely identical to the ones that were installed before, as you can see, right? Here you can see, right? The pistons are completely identical. That is, we also see 2 white oil scraper rings. We also see 2 holes for oil drainage already into the oil pan. I believe installing these pistons will prevent this problem from happening again. So that's the situation we ended up with regarding the pistons. Ideally, we should have bought pistons like the ones that were installed before. Basically, that's what I said. But somehow, it turned out that different pistons were purchased. A different design, and we all saw the result. Yeah, so what else do we have? What's special about these particular pistons? Basically, everything else is the same. Yes, I checked everything. The only thing is that these pistons have different compression heights. This piston is lower, or rather, this new piston is higher by 25 hundredths, 2.5 tenths. So I won't leave it like this. I'll be trimming this piston, just like I trimmed the pistons from the Manda 28-66 engine. I also did the same for the 501 engine. I'll be removing, well, almost 3/10. The only thing is I don't have a jig on those engines. I made a jig from old sleeves, but here I don't have an old sleeve because it was all turned into shavings. Yeah, when installing the new sleeves. So now I need to figure out what to use to make a jig, so I can clamp this piston in the lathe and machine it, well, within 3/10. Any other features? I measured the sleeves on an example, and ours are oval shaped. Well, I'll get back to this a bit later and show on camera that our sleeves have an oval shape of about 4 to 5 hundredths. So this could also be one of the reasons why, for example, the oil scraper ring doesn't remove oil from the cylinder walls. Yes, well, because we have a gap left, meaning our sleeve is oval, and in this spot the ring sits tightly. Here it fits snugly, but in these areas there's a gap between the cylinder sleeve wall and the oil scraper ring. 18 oil layer stays on the sleeve in those hundredths of a millimeter. So that's the scope of work we have today. That's what our video will be about: installing a different piston assembly on the D3010 engine. Now I'll work on the cylinder head, cleaning off the old gasket and carbon buildup. I might put it in the washer since it's covered in oil. So I'll prepare the cylinder head, then I'll work on the pistons. I need to reduce the compression height. After that, we'll install the pistons onto the connecting rods, then put the rods into the engine. Install the head, put on the oil pan, in other words, assemble the engine. That's the scope of work we have today. Let's get started. So I measured the piston rings against the cylinder liners, check the thermal clearance, and everything is within the normal range. I've checked the thermal clearance. Let's put the rings on the pistons and go install the pistons into the cylinder liners. So there's another thing. These rings don't have any markings, right? Usually all rings have markings. Like here, it might say top or have some kind of brand marking or something else. This marking is usually placed facing the bottom of the piston, like this. These rings have no markings on either the oil control or compression rings. I checked, they're completely symmetrical and identical. Well, obviously, let's say if we see a chamfer on the compression ring, we install it with the chamfer facing the piston pin, like this. If, for example, we take the oil control ring and see that there is no chamfer and no markings, then we can install it in any orientation and so on. Let's say we see a compression ring here and it has a chamfer. We install this chamfer facing the piston pin. Again, the oil control ring is symmetrical, so we install it in any orientation. Now, about the piston diameter. If we look at the piston we installed earlier, the one with the narrow ring, we see the size is 98.33. So, we take the new piston that we're installing now. I just ground it down here, so the marking is gone. But it was also written on the piston crown, 98.33. We take a micrometer and measure the skirt. So, we see the size is 98.33. Now, we measure the piston that we are going to install. We also see the size is 98.33. We have machine sleeves for a specific size, but our pistons are exactly the same size, 98.33. So you can even install the pistons randomly, meaning it doesn't matter which piston goes into which sleeve. So I assembled the engine, filled it with oil, filled it with coolant, and started the engine. Let's summarize the second engine repair. How did replacing the pistons help? That is, as you can see in the video, oil still appears on the walls. Oil still appears on the walls of the exhaust manifold. But I want to say that there's much less oil now. However, the issue remains unsolved. There's still oil in the exhaust manifold. As I said at the beginning of the video, there is an ovality of about 4 to 5 hundredths on the cylinder liners, and that's why, as a result, is getting into the manifold. What did you choose to do with this engine? What decisions were made? For now, we'll keep the engine running and observe its behavior. Maybe later I'll update you on how things are going with this engine. There's nothing we can do about this anymore. We'd have to completely remove the engine again, take it apart entirely, buy new sleeves, and take it back to the machine shop. Replacing the pistons produced specific results. From the start, I said we need to install 5-ring pistons like these. So, which pistons were installed in this engine and which should be used. So it gave us certain results, but it didn't completely solve our problems. So now we know for sure that this problem is not related to the pistons. We already know for sure that this problem is related to the sleeves, to the work of third-party organizations, and to how the sleeve machining was done. So here's what else I want to say. A new video has been released on my YouTube channel. I'll leave the link to this new video in the description below the video, as well as in the pinned comment. Please follow the link to watch my new video on my YouTube channel and support the PRO Motory project. What is this related to? I explained all of this in the previous episode in the last video. Regular viewers already know, so I won't repeat myself. I also want to say a huge thank you to everyone who followed the previous link, who watched the last video. That video got a lot of views, so thank you all very much. I'm leaving a link to the new video in the description and pinned comment. Please check it out to support the PROMOTORS project. So I'll be wrapping up this video here. Thank you all for watching. Good luck to everyone, and goodbye.